Alright, we're on the volume test review worksheet number 2, number 30. A rectangular prism has a volume of 10,360 centimeters cubed and a height of 37 centimeters. What is the area of the base rectangle? Well, look what they've given us. They've given us volume, so we know capital V, and they've given us height. That means if we write our volume formula for a rectangular prism, volume equals base area times height, we can plug in the volume, which is 10,360, and that's going to be equal to base area times height, which is 37. Well, all we got to do right now is get base area by itself. That's what they're asking us for, is the area of the base. We can get rid of the 37 by dividing both sides by 37. And you're going to end up with capital B by itself on this side, and 10,360 divided by 37 works out to be 280. So this worked out pretty clean. The base area is 280, and this is centimeters. Remember, this is area, so it's centimeters squared. So there is your answer. Try and do number 31 on your own. Alright, take a look at number 31. You should have tried this on your own. You should have gotten a base area of, I believe you should have gotten 812, and that's going to be inches squared. Alright, question number 32. And if you have a problem with that, go back and look at number 30 again. Watch the video again so you understand how to do that question. Question number 32. A cone has a volume of 75 pi inches cubed. Some of you are forgetting there's pi in there, so don't forget that. 75 pi inches cubed and a height of 9 inches. What is the radius of the base? Well, I can tell you right now, they're giving us the volume. We know we're going to be starting with the volume formula. And a cone is 1/3 times the base area times the height. So they give us the volume is 75 pi, and that's equal to 1/3. I'm going to put that in parentheses, times the base area times the height, which they tell us is 9. Now all we have to do, class, is get base area. We got to get the base area by itself first, and then from there we can find the radius. So let's go through what we learned in Algebra 1. If I want to get rid of 1/3 on this side, I have to multiply this side by 3. Because whenever you multiply a fraction by its reciprocal, in this case 3/1, those two terms will cancel each other out. And that means we're going to have to, though, multiply this side also by 3. So if we look at this, the 1/3 times 3 is equal to 1. We can cross that off. Let's go ahead and do 3 times 75 in our calculator. So 3 times 75 is going to be equal to 225. We still have pi there. And now we have capital B and 9. I'm going to go ahead and rearrange those. Put 9 in front. We're used to seeing a coefficient in front of a variable. And now you should know, well, if I want to get rid of the 9, I'm going to divide both sides by 9. And that's going to allow me to cancel the 9. And now on this side I've just got B. Now the question is, what should you do in this case? Should you just put 225 pi divided by 9 in your calculator? I would advise not to do that, only because you might end up rounding and then rounding again. Let's try putting 225 divided by 9, and let's see if it comes out to a nice number, and one that doesn't have a repeating or a long decimal. 225 divided by 9. Perfect, 25. So that means this side can just be 25 pi. Don't forget, pi has not been put in the calculator yet, so we leave it there. So now we have a base area of 25 pi. Well, we know that on a cone, we have a base that is a circle, which means the area of a circle is pi r squared. So now we can go ahead and plug in what we know. We know capital B, or base area, is 25 pi. equals pi r squared. Well, it works out pretty good. There's pi on both sides. I'm going to get rid of that, and I'm going to end up with 25 equals r squared. And you know, class, that to get rid of a square, we undo it with a square root. That means r, this cancels and this cancels. All we have is r, and r equals the square root of 25. And the square root of 25 is 5. Our unit of measure is inches. So the radius of this particular cone is exactly 5 inches. All right, pause the video and try number 33 on your own. If you do it correctly, you are going to end up with a decimal answer. Okay, we're back on question number 33. You're going to end up with a radius of 2.4 centimeters. It's approximately 2.4 centimeters. You would have gotten this, that r squared is equal to 6. So r is equal to the square root of 6. And that's where we get 2.4 centimeters. Your base area would have been 6 pi. Hopefully you've accomplished that. If not, go back and look at the video for 32 again. Let's take a look at 33. A sphere has a volume of 288 pi yards cubed. What is the radius of the sphere? Same strategy, class. We're given the volume, so we're going to write the volume formula for a sphere. Volume formula is 4/3 pi r cubed. We know that the volume is 288 pi. I'm going to go ahead and write this like I would have put it in my calculator. This is pi, and I just said r cubed, and then I wrote r squared. Very common. R cubed, and then this is going to be r cubed. Now, same rule. We want to get the 4/3 to go away. We're going to multiply by the reciprocal, 3/4. Now, hang on one second. I'm going to move. I got to do something real quick because I cannot write on that side. Let me move this over. That's not going to work. Let's try again. There, that's good enough. I'm going to move this over a little bit. There we go. Okay, so now if we're going to multiply the right side by the reciprocal of 4/3, we got to multiply the left side by 3/4 as well. And we'll see, class, that 4/3 and 3/4, you multiply those together, they equal 1. That's what a reciprocal does. It changes a number. When you multiply it by its reciprocal, it changes it to a 1. Let's go ahead and do 3/4. Oh, I can see one more thing here. Let's go ahead and do this. We can see that we've got pi on both sides of our equation, so pi cancels as well. So let's do 3/4 times 288. So we've got 3 divided by 4 times 288, and we end up with 216. So on this side we've got 216 equals r cubed. Now they're asking us for the radius. This is something that hopefully we've covered in class, but if not, I'll cover it right now. When you have a square, you can square root. When you have a cube, you have to do what's called a cube root. So your calculator probably has this. You would actually put a square root here, but you put a 3 right here. That means you're cube rooting both sides. Now, a square root cancels a square. A cubed root cancels a cube. And we're going to end up with r on this side. The issue is how do we put this cubed root of 216 in our calculator? And I'll teach you how to do this. You're going to actually find r by writing here. R is equal to, instead of writing the cube root of 216, you can write this as an exponent. And you're going to write the exponent is 1/3. So a square root can be written as a number with an exponent of 1/2. A cubed root can be written as an exponent with as a number with an exponent of 1/3. We're going to put that in our calculator and see what we get. So I will show you how we do that. In our calculator, you're going to put 216, and then you're going to raise that to the power of 1 divided by 3, which means cubed root, and that's going to give you exactly 6. So our radius is 6, and our unit of measure is yards. So just showing you how to do a cubed root to find the radius of a sphere. All right, try number 35 on your own. See if you can get that correct. 35 is going to be a decimal answer. Okay, I'm assuming you've tried this. Let's go ahead and if you work out all the same steps, you're going to end up with a radius that is going to be equal to 43.5, and that's going to be the cubed root of 43.5. You're going to put that in your calculator. Let's do that. So 43.5, I'm going to raise that to the power of 1/3, which is a cubed root, and I'm going to end up with 3.51. So that means it's going to be approximately 3.5, and our unit of measure is meters. Again, if you can't get that answer, go back to 34, watch the video again, and look at the steps to make sure you're doing them correctly. All right, we are at question number 36. Now, we got to picture this, class. 36, what is the radius of the largest sphere that can be cut out of a cube with 46 millimeter edges? So we know we're dealing with a cube here. Let's go ahead and do a quick drawing of a cube. Okay, so remember a cube is all squares, so every edge is the exact same length. And that means if they tell us that the edges are 46 millimeters, that means every one is 46 millimeters. We got length, we got width, and we got height. Now what I want you to picture in here is when it says what is the radius of the largest sphere, you got to picture for yourself, if I put a sphere inside this cube, how big can it be? Picture this. If the diameter of the sphere was 50 millimeters, it's going to be too wide to fit in this cube. Same thing about the height. If the height of the sphere, or the diameter of the sphere, is greater than 46, it's going to be popping out of the top of this cube. So the way you do this is you look at the smallest dimension that you're given. In this case, they're all the same. I'm just going to pick one of them. This could be considered the smallest. Well, they're all equal, but so it doesn't matter which one I circle. If we've got a dimension of 46 millimeters, then the radius, then the diameter that can fit in this cube is also maxed out at 46 millimeters, and that means I can just divide by 2 to find what my maximum radius is. My maximum radius will be 46 divided by 2, which is 23 millimeters. All there is to it. Find the smallest dimension, circle it, circle it, and then divide it by 2, because the smallest dimension is the greatest diameter of the sphere, and that means half of that is going to be the largest radius. Try the next one on your own, and then I will go over it with you in a moment. Just do 36, just do 37, don't do 38. Okay, we're back on question number 37. What is the radius of the largest sphere that can be cut out of the cylinder below? We'll take a look at this. If we're looking at fitting a sphere, if I put a sphere in here that is 10 feet radius or 20-foot diameter, it's going to fit exactly between the two vertical edges. The problem is it's going to be popping out of the top, because if I've got a 20-foot diameter sphere, it's going to go above the top edge. So the way you solve this problem is pick the smallest number. In this case, it is 16 feet. That's the largest diameter that we can fit inside this cylinder. Now, of course, when we put a 16-foot sphere in here, you're going to see, if I kind of just map this out for you, you're going to see that there's going to be room. Let me see if I can make that into a circle. you're going to see there's going to be room on the left and right side. That's okay. We can't go any bigger than that because if we do, the sphere is going to start popping out of the top. It's not going to be able to fit inside. So if we circle the smallest diameter and then we divide that by 2, that's going to give us our radius. So we're going to take 16 feet and divide it by 2, and that's going to tell us the largest sphere that we can fit inside this cylinder is going to be 8 feet. Try number 38 now on your own with the same strategy. Okay, hopefully you tried number 38. Now take a look at this one. This is a taller cylinder. Now the width of the cylinder, or the diameter, is 12 inches, and the height is 15 inches. Again, you've got to pick the smallest dimension. In this case, it is 12 inches. You can't fit anything bigger, any sphere bigger than a 12-inch diameter, because if you do that, it's going to start popping out of the sides. It's going to go outside of the cylinder. So circle the smallest dimension and then take that dimension and divide it by 2, because that dimension is our largest diameter. Divide by 2 and you get your largest radius. Question number 39. The object below is a rectangular prism with a smaller prism cut out of the center. What is the volume of the object? Well, we're going to have to find the volumes of both of these. So let's find the larger one first, our total shape. Let's do the large one first, the big shape. So we've got a rectangular prism. I'm going to go ahead and shade the base, which means this is my height. My base area of a rectangular prism is length times width, which is 12.4 times 7.8, and that is equal to 96.7. Now I can just, you know what? I'm going to round this to 2 decimal places, 96.72, just because I know I'm going to use that number later, and I like to have as accurate of an answer as possible. So I'm going to round this to 2 decimal places. My final answer, I'll round to 1. This is going to be meters squared. The height of the larger prism is 9 meters, and the volume is base area times height, which is 96.72 times 9. And now I'm going to round this to 1 decimal place. So it's going to be, actually I can say it's approximately, let's fix that. So it's approximately 870.5, and that's meters cubed. Now, that's my first number that I'm looking for. I'm going to put a box around that so I don't get that lost. Okay, now we're going to find the volume of the smaller prism that was cut out. So this is going to be the small one. Same strategy. What is my base area? It's going to be length times width. You can see here are my dimensions of the base right here. I'll just pick the top of this, and that's going to be 1.8 times 3. That is equal to 5.4 meters squared. Oh, that's ugly. And then the height is exactly the same. It's the same distance between the bases as the larger one. So the height here is still 9 meters. Our volume is base area times height. 5.4 times 9, and that is equal to 48.6 meters cubed. Now if you look at this class, we are not adding these two together. We're subtracting the smaller one from the bigger one because the smaller one has been cut out of the center. So when I want to find my final volume, the way I'm going to do that is I'm going to take the large and I'm going to subtract the small. So my large is 96, oops, not 96. That's why I put a box around it, so I recognize I got the wrong number. 870.5 minus 48.6, and that is 821.9 meters cubed. And I'll put a purple box around that one to show this is our final answer. All right, that's the end of the first side of Review 2.